What effect does this have on us when we unwittingly consume these products of modern genetics changes? Let's look at wheat from a blood sugar viewpoint. Anyone know what glycemic index is? It's how high blood sugar goes after you consume a specific food, right? So high glycemic index foods raise blood sugar really high, and thereby raise blood insulin really high. Low glycemic index foods raise blood sugar high, but not quite as high as the really high of high glycemic index foods. So insulin tracks with glucose. And by the way, when glucose or blood sugar goes high, insulin goes high, a high is followed by a low. Okay? And by the way, this graph, the numbers here are off. This is really about 2 hours or so, not 4 hours like the picture suggests. So high glycemic index foods raise blood sugar high, low glycemic index foods raise blood sugar high, but not quite as high. Which is wheat? Is wheat this one or this one? By the way, what if I had a 3-egg omelet with mozzarella cheese, olive oil, green pepper, spinach, and mushrooms? A big, big filling omelet. What happens to my blood sugar? Nothing. What if I have 3 big handfuls of raw walnuts? What happens to my blood sugar? Nothing. What if I have a huge piece of salmon, asparagus? What happens to my blood sugar? Nothing. Okay? So, where does wheat fall into all this? Well, sorry for this busy slide, but starting in 1981, a lot of this work is done at University of Toronto. This is where the whole notion of glycemic index started. Dr. David Jenkins, who's a very well-known nutritionist, asked this question: how do various foods affect the blood sugars of people with diabetes? So he took non-diabetic volunteers and fed them foods and watched blood sugar behavior. So he was the guy who first thought up the whole notion of glycemic index, how high blood sugar or blood glucose goes after consumption of different foods. So one of the things they looked at was sucrose, table sugar. So table sugar, no surprise, has a kind of high glycemic index of 59. And by the way, ice cream, 36. Okay, so sucrose, table sugar, raises blood sugar pretty high. It's a pretty high glycemic index. What's the glycemic index of wheat? Oh, white bread, 69 compared to 59 of sucrose. Whole wheat, 72. Now wait a minute here. We're told to eat more healthy whole grains, a food that raises blood sugar higher than table sugar. So we're talking about eat more high glycemic index foods. So high blood glucose, such as that comes after 2 slices of whole wheat bread, raises high blood insulin, okay? By the way, what's the glycemic index of a Snickers bar? 41. So by the logic of glycemic index, you should eat lots of Snickers bars. Why does that happen? Why does consumption of 2 slices of whole wheat bread raise blood sugar so darn high? Higher than Snickers bar, higher than Milky Way bar, higher than table sugar. Why? We're told wheat is a complex carbohydrate. That is, it's a long-chain polymer repeating structures of simple sugars. That's true. So this is the amylopectin A, complex carbohydrate of wheat. So you can see it's a sequence of branching glucose structures. So it is indeed a complex carbohydrate. Odd thing, the structure unique to the amylopectin A of wheat, as distinct, say, from amylopectin C in beans, is highly susceptible to digestion by the enzyme amylase. Amylase is in your saliva, it's in your tummy, it's in your stomach, and the amylopectin A is highly susceptible to that enzyme. And so that's why if I put a piece of bread in my mouth, I get high blood sugar. If I eat that bread, my blood sugar goes sky high because it has a very specific kind of complex carbohydrates. So we're told complex carbohydrates are good, right? But not this one, because this one's worse than simple sugars. Okay? So that high blood sugar is accompanied by high blood insulin. Now if I have repetitive high blood insulin every day, because I had an English muffin for breakfast, I had a whole wheat sandwich on low-fat turkey, turkey on low-fat bread for lunch, and I had whole grain pasta, whole wheat pasta for dinner, high blood sugar, high blood sugar, high blood sugar. I also had high blood insulin. Repetitive hammering away at your organs with high blood insulin causes a situation called insulin resistance or poor response to insulin. That leads to accumulation of visceral fat, what I call a wheat belly. If we look at that fat on a CAT scan, we see this on the surface, but that's not what really the problem is when you have fat. It's the internal fat. That's the stuff we all worry about. It's the fat that's in your intestinal tract, fat around the kidneys, fat, this is what Ryan Atkins would call love handles. So we have fat in the internal organs. If we biopsy that fat, it looks like pus. It's fat filled with inflammatory white blood cells. Well, that inflammation sends out signals into your bloodstream, and that mucks up your insulin response. It raises your blood sugar. It causes high blood pressure. It causes heart disease. It causes cancer. Okay? So this fat is a unique fat. This is why women who have this have 400% higher risk of breast cancer. This gives you diabetes. This gives you heart disease. This gives you cataracts. This gives you arthritis in your hips. And this gives you a lot of problems. So high blood sugar and foods that raise blood sugar higher cause higher blood insulin. And that sets in motion this whole domino effect of visceral fat accumulation. So foods that raise your blood sugar high will do this more. Eggs don't do this. Candy does it. Whole wheat does it worse. Let's talk about gliadin. Gliadin is very, very interesting. If we were evil scientists and we said, let's make something that's really bad for people, it's going to have all kinds of weird, unpredictable effects, it would be gliadin. So let me tell you about this thing. Gliadin is a fraction of gluten. So you can see wheat is not just about gluten. There's a wonderful movement. People are getting aware of gluten exposure. But gluten is a protein in wheat, but there's a whole bunch of other things in wheat besides gluten. So this movement to be gluten-free is a little bit right and a lot wrong. Okay? So one of the things in wheat, beyond just the gluten issue, is the protein gliadin. So if you're eating wheat, you're eating gliadin. Well, what does gliadin do to people? This line of research started in the 60s and 70s. Dr. Christine Zedrew at the National Institutes of Health. So we're talking about research, by the way, that comes from legitimate scientific organizations. We're not talking about this wild alternative practitioner Spokane. We're talking about legitimate sources of real science. So Dr. Zedrew asked this question: how come several psychiatric groups worldwide had noticed that people with schizophrenia is a very serious illness. It means you may never have a normal life, you hear voices, you hallucinate, you can't engage, you can't have normal relationships. She wanted to know why several psychiatric groups worldwide had made this observation, that when schizophrenics are exposed to wheat products, they have auditory hallucinations. They hear voices. They hear things like Jesus telling them to kill people. You've heard these kinds of stories. If you take wheat out of their diet, it gets much better. You give them back wheat, it gets much worse. You take wheat away, they get much better. On again, off again. These observations were made in the day that predates the need for informed consent. If I did an experiment I do today, I need all kinds of legal disclaimers and permissions, and this is tightly regulated today. But back then, you could just do things. That's what these psychiatrists did. They took wheat out, they put it back, and they watched their schizophrenics improve dramatically with wheat elimination get much worse. So Dr. Zedrew says, well, what in the world, what is in wheat that would actually cause people with schizophrenia to hear voices and have their disease be worse? Well, they took the gluten proteins from wheat and put them through a process of simulated digestion, and what she found was from that process, you get several polypeptides, small proteins, that have the ability to cross into the brain and bind to opiate receptors, okay? So wheat, gluten/gliadin is broken down into small proteins that have the capacity to cross into the brain and bind to opiate receptors, okay? So this set off a lot of research to ask, well, what happens to humans? That original study in Dr. Zedru's hands was an in vitro study, that is a test tube type of study, and mice. But these questions were then taken to human experiences. This is one such study from Michigan State University, where people were told, don't eat breakfast today, we'll feed you lunch and dinner, and you can eat as much as you want, okay? Now, they gave these people the drug naloxone. Anybody working in ER or a hospital? Well, if you did, you'd say, I know what naloxone is. That's what we give to heroin addicts when they're high on heroin, an opiate, and it makes them not high, literally within seconds. You give a person who's high on some opiate drug, you give them an injection of this drug, naloxone, often called Narcan, and they're immediately, you erase the effects of the opiate drug. So it's very potent, very effective. Well, these people were told, first of all, don't eat breakfast, come in for lunch, eat all you want. So these people ate around, what, 1,100 calories for lunch. And then for dinner, had about 900 calories, okay? And then they came back some days later, but this time, same experience, but they were pre-injected with the drug naloxone. And then said, same process, go ahead, have lunch. They ate about 700 calories. Dinner, about 700 calories, for a total of 400 calories less in that day when they were given an injection of an opiate-blocking drug. So this has been done in normal people, that is not people who are addicted to opiates or heroin. This has been done in people with binge eating disorder. These are people who, once they start, they can't stop. Same kind of study. This is kind of evil, but they put people with binge eating disorder in a room, and on this table, it's a table of cupcakes and cookies and cake. They said, go ahead. They did. They counted up the calories. They brought them back. A few weeks later, this time with an injection of this drug, naloxone, did the same thing. Go ahead. Eat all you want. Counted up calories, 400 calories less per day. So this observation is held up time and time again, that if I give nice, normal people or people with eating disorders opiate-blocking drugs, they eat 400 calories less in a day's time of pies, cookies, and cakes. Okay? By the way, a drug company just filed its application 6 months ago for the drug naltrexone. Those were observations of the drug naloxone, but there's an oral equivalent called naltrexone. Naltrexone's already in the market. Heroin addicts take it. They take it to block the highs. They try to stay drug-free. So they take a high dose of naltrexone. Well, this company filed an application with the FDA about 6 months ago for the drug naltrexone at lower dose for weight loss. Because in their clinical trials, people who took this oral drug naltrexone, this opiate blocker, lost 22.4 pounds in the first 6 months because they ate 400 calories less per day. Okay? So what effect does this have? So we have a USDA, we have a U.S. Department of Health and Human Services who tell us through the dietary guidelines for Americans, eat more healthy whole grains. Combine that with Dr. Wallach and the geneticists' effort to increase yield and the introduction of the high-yield semi-dwarf variant with unpredictable changes in genetics. So Wallach invented this in the 60s and 70s. It was introduced into most farmers in the 70s. You know, once you have a strain, not all farmers adopt it. It happens gradually over years. Well, by the late 70s, a lot of farmers had adopted it. By the mid-80s, everything you were sold came from the high-yield semi-dwarf plants, okay? So what happened to us when we were told, one, to eat more healthy whole grains, and people listened, and then two, the wheat was different, but mostly in the late 70s into the mid-80s, when the high-yield variant finally hit the store shelves at Pick and Save, Piggly Wiggly, etc. So what happened to wheat? Oh, it starts to go way up, because we have a nation eating about 400 to 500 calories more per day. Do that day after day, you gain a lot of weight. Now, I'm guilty of an oversimplification. Obviously, there are other trends in here too. So maybe some people gain weight because they drink Coca-Cola, or drink Kool-Aid, or play Xbox for 8 hours a day. But not most adults, right? Most adults don't do that. What happened to diabetes? So if I increase my calorie consumption 400 calories per day, let's say I gain 25 pounds this year, do I become diabetic right away? No, there's going to be a lag. Maybe I have to gain 30 pounds, or 40 pounds, or 50, or 60 pounds before it shows itself as diabetes. So there's a lag. So the high-yield semi-dwarf variant of wheat was introduced in the mid-70s. It starts to be adopted by more and more farmers. And then by 1985, where virtually all the wheat you were sold, all the breads, pasta, cookies, cakes, pretzels, crackers, pancakes, waffles, breakfast cereals, were all the high-yield semi-dwarf variant. And what happens? You heard the rest, right? This is the graph from the CDC up till 2009. If I showed you the newest data, they haven't published it in a graph form yet. You would see that the curve for diabetes is now vertical. It means that everyone here in this room, according to their predictions, will be diabetic. Virtually everybody will be diabetic in the coming years. That's what they predict. And what is their explanation? What does the CDC, the USDA, the U.S. Department of Health and Human Services, all official agencies, what do they attribute this to? They say, it's your damn fault, because you're lazy and you're a glutton. And if all you did was cut your calories and exercise 90 minutes a day, you wouldn't have this problem. Let's talk about lectins. You and I, if we have an invading organism in our bodies, we fight it off with antibodies, right? And other mechanisms. So we're protected to some degree from viruses and bacteria. Well, plants are not quite as complex as mammals, as animals. So they have a different kind of protective mechanism, and among their protections is something called lectins. Lectins are glycoproteins, and they protect the plant against fungi, molds, and other predators. I love this little picture. It's from a blog that a biochemist who calls himself Paleomog writes. Well, lectins, the lectin of wheat, so virtually all plants, nearly all plants have a lectin, a protective glycoprotein. Wheat has a very, very unique lectin. It's called wheat germ agglutinin. So it's richest in the wheat germ. Okay? People think wheat germ is healthy. Well, wheat lectin is indigestible. So you eat it, it gets into your intestine, and it has a very, very odd ability. Believe it or not, your intestines are really smart. They may not have high IQs, but they're really good at telling what should be able to get through into the bloodstream and what should not. So if you eat something, not everything you put in your mouth and gains access to your intestinal tract belongs in your bloodstream, right? So your intestine sits there and says, okay, you can get through into the bloodstream, but you can't. Because there's lots of things in your intestinal tract besides food, right? There's bacteria, there's bacterial byproducts. In fact, you're filled with bacteria. So the intestine has to be smart and discriminate what can get through and what can't get through. Well, lectins, wheat germ agglutinin, the lectin of wheat, has the very peculiar capacity to disable that selectivity. It essentially unlocks the normal intestinal barriers, and it lets lots of things through. That's why many people have antibodies to wheat germ agglutinin. We're not supposed to have antibodies to wheat germ agglutinin. It's not supposed to get into the bloodstream. It's a big protein. But a lot of us have antibodies to wheat germ agglutinin.